everybody. All right, in this video, I'm going to teach you guys how to find the end behavior for exponential functions. All right, looking at this first example. Now think about it. When we say the title end behavior, we're talking about the ends of the graph and basically the behavior of the ends of the graphs, right? So with these exponential functions, you have two ends. You have an end over here on the left side where that left arrow is, and you also have another end on the right side of the graph. So basically all we're going to be saying is, hey, what are the x values doing on the left and what are the y values doing on the left side? What are the x values and the y values doing on the right side? All right, so as you can see on the x-axis, my x values over here on the left side are these numbers right here. And even though I cut this graph off, it keeps going all the way to negative infinity. That's why you see in my first statement for the left side, I say as x approaches, that's what the arrow means, x approaches negative infinity. And then if you look on the right side of my x-axis, you see 1, 2, 3, 4, and it keeps going. Even though I cut off my graph, it keeps going all the way to positive infinity. So that's why I wrote on the right side as x approaches positive infinity. Those will never change because the x values will always keep going to the negative infinity on the left side, and they'll keep going to positive infinity on the right side. Now what can change is what the y values are doing. All right, so let's just look at the left side. We just said that my x values will be going all the way to negative infinity. Now, for the y values, you have to look and see what that arrow is doing. And as you can see, it's getting closer and closer and closer to that asymptote. My asymptote is at the number 4. So my y is going to approach 4 on the left side. So as x approaches negative infinity, y approaches 4. Now let's look at just the right side. Just like we said, the x values will keep going to positive infinity. Now, looking at this arrow right here, as you can see, it is pointing up. And it keeps pointing up and going to positive infinity. So therefore, my y is going to approach positive infinity. So my end behavior is as x approaches negative infinity, y approaches 4. And as x approaches positive infinity, y approaches positive infinity. Let's look at another example. All right, like I said, the x will always approach negative infinity on the left side, and the x will always approach positive infinity on the right side. But just like the last example, let's look at the left side alone. All right, like we just said, we know that on the left side, my x's are going to always approach negative infinity. But now let's look at the arrow to know what the y is approaching. Yep, it is pointing up, and that means it's going all the way up to positive infinity. And by the way, if it was pointing down, you know it goes to negative infinity. So on the left side, as x approaches negative infinity, y approaches positive infinity. Now let's look at that right side of the graph. Just like we always said, your x will always approach positive infinity on the right side. Now, to know what the y is doing, let's look at that arrow. As you can see, it's getting closer and closer to the asymptote. And my asymptote is at 2. So therefore, my y is going to approach 2. So on the right side, as x approaches positive infinity, y approaches 2. And this is my end behavior. That's it.